So we'd have expected all these problems to be kind of picked up in testing, wouldn't we? Yeah, that would seem a reasonable assumption. What is the point of testing? Why do we test? Why do you test? You've all said you do testing, which is great to hear. Why? Anybody? Why do you test?
Sure, it meets the requirement.
Meets the requirement. Sorry? Okay, I'm sorry, I can't hear you because there's a loud fan over here. Refactoring the code, that's an excellent one.
Catching known bugs, so once you find a bug, you want to test the place.
So regression testing. Yeah, regression testing, those are all excellent things. There's another reason, especially for developers who are hands-on writing code all the time, we're going to urge you to put even more emphasis on testing than you do already. That's because if you consider yourself a software engineer or a computer scientist of some kind, and you're following some sort of scientific method, your tests are your proof. They're the proof that what you think the code does actually is true. That's what they do. Because it's my experience, and this is a growing problem in my experience, developers don't read their own code accurately anymore. I'm not talking about misunderstanding algorithms. I'm talking more fundamentally that they'll see a piece of code and they'll say it does something completely different to what it does. And that comes back to I've seen this increasing a lot since things like PSR2, automatic code formatting came out. It's to do with how humans read. If you think about how you read a book, you're reading every single letter and every single word when you read a paragraph? You don't, do you? We scan, the brain latches onto shapes and assumes that that's what the word is. That's why we can read paragraphs with quite a lot of words missing, and why people can read SMS text with a lot of letters missing. It still makes sense, because the brain will fill in the gaps for us. That's what the brain does. But when we're doing that with code, especially if all the code's in the standard format, and I've seen this firsthand on projects, I've had to sit down and write tests for developers and show them that their code was completely different to what they were reading. They read something completely different. It's just the way the brain works. So it's something to be careful of, and a reason why I'm a big, passionate believer in aiming for at least 100% code coverage. And if you don't aim for 100% code coverage today, air conditioning is determined to be the star, isn't it? Yeah. Well, at least it's stopping us all sweating to death, so take that. If you are interested in arguments for 100% code coverage, I did a talk in Glasgow last year. That was videoed, and the slides are online. I urge you to go and watch that, read the slides. Some of the slides are going to come up later about that. Because how does testing help us ship things faster? How does it help us actually get software out the door quicker?
Faster feedback loop.
Faster feedback loop, yeah? And why does that matter?
Spot things faster.
Spot things faster. Why does it matter that we spot things faster?
Fix it faster.
Fix it faster?
Why it happens.
Okay. Okay. And what are all those things preventing?
More bugs or fixing down the line.
Yes, they're preventing rework. Those of you who run budgets and have to make a payroll, you will know that rework is a massive problem and a massive enemy of making that payroll. Because it's extra work. You're paying for work to be done twice, 3 times. As a developer, it increases the amount of time it takes you to ship code. That's why we want to be able to iterate faster, so we catch all these problems in the smallest, fastest possible loop, iteration loop, of working, so that it's not going out to a customer and back. Because rework is expensive. When I did my degree at at Sheffield University of Sheffield, sorry, we were taught, maybe you've heard this, in any phase of a project, any bugs that slip through, fixing them in the next phase costs 10 times as much as it would do if you'd caught them first time. That 10 times factor. Have any of you ever heard of that?
That's an IBM study in the 60s.
IBM study in the 60s.
Fixed to date and
Right.
tomorrow it's 10, after it's 10.
That's awesome, because I've never actually found a reference for it. When I was doing the research for the Glasgow talk, the best I could find was a different IBM study that said it was about a factor of 3.3 in there. That was the only one I could find cited anywhere. But to know there really was one for 10 times is awesome. I'd love to track that down. But even 3 times, if you put that on a graph, that's what it costs. If bugs slip all the way through. Now, hopefully, that's not very nice when you see it. Yeah? But if you say something can get through, and it'll be cost until it gets out to the customer, because it was a design problem, it's a huge cost to fix. How many of you have had to go back to the drawing board because you or the organisation you've been in have shipped code, and when it's got into the hands of customers, there's been fundamental problems, not with the coding, but what you were asked to code? Yeah? I mean, that's the whole premise of Agile with a small a, isn't it? Is to reduce, again, that feedback loop, to reduce it down so you're catching problems as quickly as possible by having the customer, the expert user, as part of the development. Yes, please.
Usually that results in less analysis.
Less analysis.
And less analysis means that
Yes.
this comes in.
I absolutely agree. The art of business analyst is almost dead these days. I would argue the art of project management is also dead as well, which isn't helping. But we can talk more about the pros and cons of Agile down the pub, I think. I think that's probably safest. Hopefully, none of you are happy with this. You wouldn't be happy having to deal with these kind of costs yourself. So, what kind of testing can we automate? What kind of testing do you do? Anyone, please.
Feature testing.
Feature testing? Okay.
Integration testing.
Integration testing? Yeah. Someone's already shouted out about unit tests, so I'll give that one for free. As you've mentioned, integration testing. You called it feature testing. I would call it functional testing. And what I mean by functional testing is an end-to-end test that also does deep inspection of the results. It's not just looking at an API response or looking at what's rendered on the web page. It's also going into the database and making sure the database has been updated correctly. It's also making sure any emails that are supposed to be triggered has been sent, that kind of thing. It's a very heavy piece of proof. The flip side of functional testing is non-functional testing. Back when we had specs, etc., they used to be divided up roughly into these 2 sections. And your non-functionals are things like your performance, your scaling. Security often gets put in as non-functional rather than functional, but you can argue either way with those. It's those kind of things. It's generally, you could argue, it's operational testing. All the things that are needed to operate the software once it's been shipped. Acceptance testing. What you may know as BDD, with BHAT and such similar tools. That's not functional testing. And I've been having this argument with the BHAT authors since we all started this stuff many years ago. Hi, Konstantin. So acceptance testing is different because it's lightweight. It's using the customer's language. That's why BDD is so good for that. And it's just doing the same kind of things the customer would do if they were sat down in front of their computer doing manual testing. That's all it's doing. It's lightweight, it's quick. Now, which of those actually helps us? Which actually helps us iterate faster? If you could do all this on your desktop or your laptop, which of these would actually speed things up? If we look at that list. Do you think all of them? UAT, user acceptance testing. Yeah. I'm going to lump that in with acceptance tests for the purpose of these slides. You're absolutely right. Anyone else? Is there anything in there you'd take out? There's one you can take out. You don't need integration testing in reality. If you've got end-to-end functional tests that are doing deep inspection of the systems as they go along, because it's an end-to-end test, you are effectively doing integration testing as well. You could argue it's not as thorough as a dedicated integration test, but for the purposes of shipping code that will work for customers, in practice, the results are good enough in my experience. And most firms can't afford to do it. Integration, actually formally writing tests for an interface is a pain in the backside, especially in modern web APIs that change constantly. You end up putting a lot of money into tests that rot very quickly. So I would argue integration test is the one you can safely skip, provided you've got the others. But the others, you may not be able to do them all on your workstation. Non-functionals for scaling, etc., can be difficult. Sometimes you've got to throw a lot of hardware at those, or a lot of Amazon instances to make that happen. The rest you need, I would argue. Now, these types of testing, are they good all the time? Do they work in every circumstance? How many of you use unit tests to test your controllers or your actions or whatever they're called inside your frameworks of choice? Your domains, yep. How many of you use your unit tests to test your ORMs or the models they generate? I assume you're using Doctrine or, I don't know what Laravel's is called. Eloquent, yeah. I assume you, and how many of you are using unit tests to test those kind of things? Okay, right. I don't. I'm a great believer that to go faster, you have to have a toolkit rather than a two-headed hammer. I should have really found the old PHP. Have you all seen the PHP photo? The PHP's accused of being the two-headed hammer? No. Okay. I should have found that for you then. That is an accusation of PHP. That's actually a very blunt instrument. And so someone came up with the concept of this two-headed hammer as a result. But I don't do that. I think unit tests are best done on libraries, or composer packages if you like, because they are decoupled from the context that they're used in. They're decoupled from your application, if they're designed right. And unit tests are great for making your libraries testing your libraries and getting them shipped faster. For your app, your controllers, your models, etc., functional tests will get the job done quicker. If you've got a lot of functional tests covering what the user's actually trying to do, all the different ways they can do it, you'll exercise the code good enough. And you don't need you don't need to write unit tests for all of that in order to ship code quickly. It's great if you can afford to do the unit tests as well, but that's a lot of extra time. And given the choice, if I can only have one, I would have functional tests every single time. If we go back to the system where the team was very focused on the metrics, they did unit testing for all of their parts of the app. And it wasn't good enough. Acceptance tests, they're there to help us build quicker. I am showing my age there from back when I joined the industry before we had the commercialized web, you see. But the main thing with acceptance tests is so you can send an invoice. We literally used to have managers stand over us watching the acceptance tests go through so they could put the invoice out the door, especially in those days when it was all snail mail. It wasn't done electronically. Many contracts in firms, acceptance tests are the criteria for triggering payments if you're doing fixed price projects rather than time and materials. I got ahead of myself, I'm sorry. The team that focused on the metrics didn't focus on the testing. Their testing wasn't catching, the fundamental problem was they weren't thinking about how users were going to use the system and everything involved. They hadn't identified all the actors correctly. And as a result, the testing didn't cover everything those actors could do. In fact, one of the actors wasn't even covered at all as a result. Not only did that team miss it, but their customer missed it until it went into production as well. It was an oversight of everybody. It was a problem that everyone only noticed once it was live. So it wasn't like the team dropped the ball or anything. It was something that was completely not thought about at all in the same organization. They were using unit tests for everything. They didn't have functional tests that I would recognize. And they were using mocks as well to mock out some of the things they were talking to. And as a result, you have a lot of tests. All their tests passed. They had more tests than any other team in this organization. But unfortunately, the tests weren't worth a damn in reality. I felt really bad for them because they put all this time and effort into this beautiful test suite, and the code fell apart in prod. I felt really bad for them. The functional testing they did was what's often known as key batch testing. Someone sat down manually going through a test script, an old-fashioned written document saying, do this, do this, do this. Humans are shit at that. They absolutely are. We are crap at doing things 100% reliably. Never rely on one human to do something 100% reliably. They may manage it some of the time, but they're not going to manage it all of the time. And the other problem was they weren't doing testing in an environment that looked like production. So the testing they were doing was not going to exercise some of the problems they ran into in production at all. It couldn't. It was never going to succeed because they'd not been provided with that environment. Which leads us on to the last part, which is deployment, the last section of the talk. So, how does automating deployment help us? How does it speed things up? Those of you who do automate deployment, do you feel it speeds things up?
Yes.
Absolutely. Yep. You're looking less convinced.
Yeah, no, it does.
Okay.
Right, information doesn't.
Writing the automation doesn't. Hold that thought. We're going to come back to that. Yeah. For the rest of you, we need somewhere to run that code before we ship it. Hopefully you're all trying to run the code on your local workstation, or your laptop, your desktop, or whatever. What do you do when you run that code locally? Can you spin up an environment that remotely represents your production environment? Couple of nods. How about the rest of you? Can you do that? No? Not in your day job. Okay. Right. For those of you who can you run it in the same place that your dev tools run? You can. Excellent. That, for me, that's a very important criterion. We've got all these debugging tools, IDs, etc., that can connect to something like Xdebug and use that to single step through code if you need to find problems. But they don't like working remotely. They work best where everything's all in one place. So it's very helpful to be able to spin things up on your dev box. The other thing is, your dev box is yours. You're not sharing it with anyone else. You're not fighting over resources. So there's less bottlenecks as well if you can run everything locally, which will, again, help you find problems quicker. Now, deployment, I always recommend it split up into two separate layers, two separate activities. Being able to spin up the environment, and then separately being able to stick code into that environment. So that you can spin the environment up once, and then constantly put code into it without having to destroy the environment and recreate it. Because recreating environments, even if it's all automated, can still, and normally take minutes, it can sometimes take a lot longer than that. It can be a real bottleneck. But if you've got environments automated, you can destroy it once a week and then put everything in, again, to stop cruft building up and stop you getting false results. So I recommend these. They've got different release cycles. Please don't merge them into a single activity. I've done that. And I was hated for it. That was a bad mistake of mine. I absolutely made that mistake. I built a test tool called Story Player for doing deep functional testing. And it will spin up a whole test environment and then deploy code into it and then run all the tests and then destroy it all. Which meant if you wanted to do functional testing, it would take up to an hour to do that test run, which was too slow. Because at that time, my criteria for what automation is there for, I would argue hadn't evolved enough. I wasn't thinking about how we make things faster. I was thinking how we make things more accurate, more correct. There's no point making things correct if people will work their way around it because they can't stand waiting for it. That is a bad mistake I've made myself. Now, when it comes to taking that code and shipping it to production, your live environment, wherever that is, how do you do that? What do you do today? What tools do you use? You've mentioned Deploy HQ. I believe you mentioned shell scripts. Yeah. What about the rest of you? How do you ship code to live? Are you just FTPing it up onto a server?
Using that called deployer. It's open source.
Okay.
I think it runs exactly like Deploy HQ and Envoy for the Laravel.
Okay.
It runs like that, but it's an open source thing.
Right. Okay. So what you're talking about there, I assume, is predominantly something that runs on your computer and uploads code directly to a live machine.
This runs on a server.
It runs on a server?
Yes.
Okay. Right. And when it runs, sorry, I'm curious to learn more about this. What does it actually do? how does it get the code onto the live server? What steps does it take?
Checks out from Git, then it runs composer install, and then it runs a load of other steps you can define. So
Right.
for us, it does things like restart the queue workers, restart, well, regenerate some documentation as well.
Okay.
Before it then actually activates the release.
Okay.
It does in release. So we've got like 4 releases already in the server, so we can roll back as well if we need to.
Okay. So that sounds like it's doing a form of orchestration. But it's all triggered by commits to Git, is it?
It can be, but we've got it on a manual. You have to.
You've got it on a manual.
You have to click deploy.
Okay. That's not necessarily a bad thing.
Yeah.
A lot of things these days are triggered by a commit to Git. And the buzzword for that is often called GitOps. But if I was in a room with 30 people who did GitOps, they would probably give me 30 different explanations of what it means to them and how it works for them. But fundamentally, it's the idea that when you commit to Git in the right place, it triggers everything else. You've mentioned shell scripts. This is a favorite of mine. I love writing shell scripts. I've been using Unix for decades. It's the one true operating system and all that. But I can't grow a beard, sadly, so I'm ostracized from the Unix community. Oh dear. No, you can get a lot done with shell scripts very quickly. And the example we heard there was a kind of orchestration tool. Now that's commonly a term used to cover things like Chef, Puppet, Ansible, and Salt. And CF Engine is still around as well. Anyone remembers that from back in the day? So those are roughly the 3 ways people do automation. Now, the thing is with GitOps, it has normally got an orchestration tool hiding behind it. It's very rare that you commit to Git and there's nothing else, there's very little involved in actually getting it onto the live box. And so if you're introducing that kind of automation to your organization, you've got to think about, well, how your developers, how you as a developer are going to do that local deployment? How are you going to deploy it locally? Because if you're not using the same tools that's deploying to production, there's a gap. Things can fall down into that gap. So it's something to be careful of with automation. You want to be able to reuse automation in as many different places as you can, as is practical and pragmatic. Shell scripts are wonderful, provided everyone's using the same operating system. Even using different Linux distros is enough to break shell scripts, sadly. But certainly these days, mixed Mac and Windows environments are very common. Very common. Now, Windows, you've got is it called WSL? That will run a Linux subsystem, I believe. I haven't used it myself. I'm celebrating 12 years Windows free and counting. Personal preference. Personal preference. Most of the PHP community is moving back to Windows at the minute for development, interestingly enough. Which means if you're a Windows user and you're fed up of how badly things work on Windows, you should see some improvements over the next few years as core committers, etc., start to sort these frustrations out because it's finally hitting them. The point that was made earlier, if you're using orchestration tools, developing the scripts for them takes a lot of time. I've just taken on a client where I'm actually helping them with creating scripts for Ansible. And something that would take me half an hour to do with a shell script takes days to do with these tools. The tools themselves are slow. The way you develop with them is slow. The ability to reason about what they've done and debug them is slow, because most of these tools were not created by developers who are looking to iterate fast. They're created by people looking after boxes who want to solve their problems, which actually is the history of computing here in the UK. When I came to Sheffield and was at the department, it was largely staffed by lecturers and professors who'd come over from other departments because they needed better computers to solve their problems back in their department, and they just never left. Whether the problems got interesting and they got involved in it, or they just couldn't get out, take your pick. But that's the history of computing here in the UK. It's people go and solve their problems that they're faced with, and you can end up with very interesting tools as a result, but tools that sometimes would have been better if they'd been written by different people. And orchestration tools fall firmly into that. The other thing to note about automation is its code. And I'm sure you're all aware that code rots. And it feels like code's rotting faster than ever as time goes on. A lifetime before code has to be updated, even though you've shipped it and met the spec, in order to keep on top of framework updates, etc., keep on top of operating system changes, all those sorts of things, so that what you've got today will still work tomorrow and still be reproducible tomorrow. It all rots. So automation of deployments is a constant investment. I've seen firms put all the effort into creating all of this and then move staff onto other things, or they would do was done by contractors who left, and then the automation gets into a pickle. And of course, all the knowledge about how everything works is in the automation, it's not in people's heads. So that's something to be careful of. It's one of the trade-offs with automating is. And very importantly, automation really doesn't survive when paradigms change. And we're going through this right now in the industry. How many of you use Docker or another container technology at the minute? A couple of people? You will be. Containers are becoming, slowly but surely, the standard way of packaging and delivering software in one form or another. Those of you who use Linux, Ubuntu Linux with snaps, they're a container technology. Ubuntu are trying to ship whole applications as containers, your desktop applications as containers. They're being met largely by apathy, to be honest. But it will grow. Certainly all the clients I work with down in London, I've been using containers now for many years. And all the work is for containers. Containers are nice because you can run the exact same package on your machine, in your test environment, and in production. Because you ship the actual container and all its contents, which means you're guaranteeing the same software everywhere, which can eliminate a lot of problems. How many of you have heard of Kubernetes? Yeah? Anyone had a play with it? No? So this is the end game with containers. And this is where the paradigm shift is going. Kubernetes is a system where you describe what's supposed to happen on there, and it will go away and make that happen for you. Which means, if you think about when you write a shell script to do deployment, it's a sequence of steps. And you know that one step will finish before the next step starts. It's a serialized process. With Kubernetes, it's not even asynchronous. You're uploading a description of your production service on there, and eventually something will happen. You can't control the order of it. You can't control the timing of it at all. And Kubernetes will move things from box to box in order to deal with hardware failures, to deal with load, etc. That's where these platforms are going. And tools like Ansible, which is what I'm using at the minute to actually deploy stuff onto Kubernetes. Ansible's been around, 4 or 5 years now. Most of its modules are useless with Kubernetes because they're written for logging into real servers and doing things, or virtual machines. You don't log into containers. Once a container is built, if you're writing to that container at all, your container is badly designed. Containers should be treated as read-only, immutable cattle. You're familiar with the pets versus cattle thing? No? Okay, I wish I had a slide for that. The idea is you should treat your production environment, your services, as cattle. You can slaughter them at any time and replace them. You don't treat them as pets to be lovingly nurtured and kept alive as long as possible. If you have servers with huge uptimes, how many security defects haven't been patched properly as a result because you've not rebooted into later kernels? How many processors are still using the version of OpenSSL that was installed when they started, rather than ones that have been installed and downloaded since, for example? So the idea is you treat your servers, you treat your production services like cattle. You make sure you can slaughter them on a regular basis. It's a grim analogy, but it works. And Kubernetes is sort of the end game of where all that is going. But if you're investing a lot in automation today, you've got to be careful with it because it won't work if you move on to these kind of platforms. So that's my tour of automation. for developers. What do you think? What are your thoughts? Those of you who don't do automation at the minute, have you seen anything in there that you wish you had?
So there was one, I just thought afterwards, tool that wasn't mentioned. But it isn't all the tool, there's make.
Ah, yes, for doing builds.
Well, even if it's just minimizing JavaScript or SASS and so on, you can save quite a bit of time.
You can. Problem with Make again is like shell scripts is portability, sadly. Although GNU Make is available everywhere these days. That's interestingly, a lot of the automation tools we have today actually owe their existence to Make. Any Java people here? Java developers? Have you heard of Ant? One of the very first build tool for Java. If memory serves, it was invented because the authors of Ant couldn't write Make files. That's why they started it. With Make, indentation matters, and it's very fussy and a pain in the backside over it, I could argue. So they invented Ant instead because they hated writing Make files. And practically every automation tool of one form or another can trace its lineage back to Ant or reaction to Ant today. So, yeah. So, are any of you not convinced? Any of you thinking that you're going to go back and you're very happy with how things are and you don't see a reason to automate anything? I'm not looking to embarrass or call anyone out. What I'm looking to do is to learn. Okay?
I think it's been about being pragmatic about what you should automate. The stories you're telling about over-automation. I think are good points because time and money don't allow to over-automate most of the time. But there's a balance to be drawn there, isn't there?
There absolutely is. There absolutely is a balance to be drawn and a pragmatic approach. Automate. That's why I've shifted my thinking from using automation to guarantee correctness to using automation to make things faster. Because if it's not making things faster, you can't afford it. Especially in today's economy, where margins, if you run a business, margins are tighter than ever. I've been self-employed on and off since the 90s, and margins are down 25% over that time. Even though the industry is far larger, and I am far better developer today than I was 25 years ago. In real terms, I make 25% less with my business than I did back then. Even though there's more demand on everything, because there's less money to go around at the end of the day. A lot of the projects that you do, they don't make a lot of money for anybody, really. If margins are tight for everybody. So anything you can do to speed things up can make a big difference.
I would disagree.
Okay.
I worked for a firm a while ago.
Yeah.
I don't see who it is. And I was just explaining before you started that they were basically wanting a baby.
Okay.
So their idea was you get 9 women pregnant for a month because it takes 9 months to get a baby.
Yes.
They just threw teams of people at the project and through teams and teams, and they almost had a bus service to Bangalore to bring people in.
Yeah.
And they just drowned under the weight.
Yeah.
It just never worked.
So they obviously never read the Mythical Man Month then. No. In project management, there's a truism that 9 women can't make a baby in 1 month. Some things just take as long as they take, and you have to live with it. You can't force it. And throwing more and more people at it just burns money. It's a lesson every generation seems to need to relearn. I think it would be fair to say.
Near the start of the talk, you mentioned that you don't use tools to automate your writing code. Why is that?
Because I'm trying to develop habits. Sometimes I'm working on code bases that I'm not familiar with, that I haven't written, and I need to be able to take them apart and explain to the people who did write them why it doesn't work. That's why people hire me. So I also need to be able to write code and ship code and have it stick very quickly as well. And what I find is it's the use it or lose it approach. If you offload too many things to automation, you actually forget how it works, and you lose the ability to do it yourself. Sometimes quickly, sometimes at all. You forget at all how it works. And if you're jumping around from project to project, I will often have 2 or 3 projects on the go at once. If I'm jumping around from project to project, and I'm forgetting everything, and I come back to the project, the time it takes me to pick up and relearn the stuff is a major problem for me. So for my circumstances, I'm a faster coder by doing quite a few things more manually.
I think that's a good point. Because I've seen a lot of developers like using aliases, sort of command lines to do things. I find that one of the risks there is you build these aliases and then the minute you get put in front of someone else's machine, you don't actually know how to do what you want to do.
I saw that a few weeks ago. I was at a meetup where someone else was speaking, and they were doing a live demo, and they'd aliased everything so it would fit on the screen. So anyone who was watching that live demo, the person talking, he did explain what the aliases meant, but all you saw on the screen was the aliases time and time again. So I do, as you know, take your point. I wonder how many of those people took anything away they could use.
I found as well in the current place I'm at, using things like the, one of the other people that I work with use code completion tools. And things like spelling mistakes crop up because they've used a spelling mistake to then generate a whole class or file, function, variable name. That and spelling mistake is across the whole code base. And then when I joined the company and I started trying to build stuff for it, and I'm spelling stuff the correct way it was spelled, and I'm like, why are my classes working? Because then you used the code completion and not realised, and obviously the tests and stuff didn't pick up a spelling mistake because as far as the test was concerned, it was passing.
Yeah.
So I think that was another reason why I've avoided those kind of things as well, because of those things.
There are established APIs out there where that's the case, and it's frustrating if you hit it because you don't know whether you're hitting the part which hits your part you're whether it's
And API specs as well, not just shipped code, but actual specs for interoperability where the spelling mistakes have been incorporated. Yeah. No, that's a very good one. I hadn't thought of that, but that is an excellent point. Anyone want to contribute anything else before we wrap up? Great. Well, thank you all very much. You've been a great audience.